Hi, my name is Paulo Khayat. I am the head of programming in our team, Galaxia, if you weren't here in the last webinar. Now, a little bit about Galaxia. Second is setting up the split. Never mind, I don't think. Okay, so we're Team Galaxia 5987 from Israel. We participate in the FRC competition, a competition that's similar to yours, scale. Since last year, our team has been helping Romania as part of our team's vision to help spread first in the community and make sure that the FTC teams have the best experience they can. Okay, so this is the second webinar of the 3 webinars. The first webinar, we sort of talked about basics of Java for the people that don't know programming language. And then the next 2 webinars, we'll be talking about the specific things for your competition. Starting off with the electronics. It's going to be a little bit of a shorter webinar, which will talk mostly about what connects to what, meaning of the code. And last webinar, we'll talk about how the code works and how you make robot run work. Okay, so there are 2 main circuits that you will use. Sure, ones that buy them yourself, we do, but I'm going to show both of you. The first of all is the modern robotics board. The modern robotics board is the older circuit board, our team, our FEC team. It's not that complicated. You have the phone itself, which has all of the information that you're going to need. And then it connects by cable, by a USB cable, to the core power distribution model. Now, the core power distribution model connects to the power battery, and then the power distribution model, hear me very bad, hold on. I'm going to try to can you understand the things I'm saying? The microphone is something a little bit wrong with it. Echo. A lot of static, right? I'm gonna try to speak anyway. Sorry, this is gonna try to find a solution. Right now, I don't think we have a microphone. We have one. Yeah, but I'm fine. Okay. Hello? Wait. Hold on, now I can hear me. Is this better? Okay. So, as I was saying, this is the modern robotics board. What it does is basically takes information from the phone, sends it to the core distribution model. Gives the core controllers the information and the power. Okay, so there's 4 core controllers. There is the motor controller, the servo controller, the legacy model, and the device interface. So the DC motor is just like the motor controller is just what it sounds. It can control 2 motors and the 2 encoders for both motors. The servo controller can control 6 servos. The core legacy model can get Lego sensors, and the core device interface can get the modern robotics sensors. Here's an example of a setup of the modern robotics. And this is the new rev circuit board. Now the rev circuit board, it's not as complicated as the modern robotics. You have one circuit that controls everything on the robot. It has 3 parts: the motors, the PWM, and the rest, which is sensors. So this is the newer version, and it's cheaper than the previous one. Basically, this is the better alternative if you had the choice. The power connects to the expansion hub through these cables, and then there's 4, not 2, connections to the expansion hub for motors and encoders. There are, the interruptions. Yeah, I'm gonna try to eliminate the static, but I don't think I can. It's a problem with the specific microphone. Sorry. Oh, okay, I can. Yeah, go. Hold on. Did the echo stop? Okay, it was from my own headphones. So the switch expansion hub basically controls everything in the competition, unless you need more than 4 motors, and then you buy 2 expansion hubs and connect them to one another. Now, what's the difference? I sort of talked about it. Both of them have advantages and disadvantages. The Rev is cheaper and more compact, and it takes like less space on the robot itself, has fewer types of connections, and it's new. The core legacy model, which is the previous one, is more, it's compatible with all the motors of previous years. Let's say if you're not a new team, all the motors you used to have still work with it. And the fact that it's not one electronics board allows you to lower the budget depending on what you actually need. Okay, like let's say I want 4 motors, but I don't want servos and sensors. I could only buy the 4 motors, then it would be a lot cheaper. On the other hand, if you want to buy, like, have a lot of motors but not all the other things, you have to buy the whole rev expansion for those extras. This is some of the actual costs. This is really part of our rev is a lot cheaper. Okay, so next I'm going to talk about the phones themselves. Now, the phones themselves, are the things you connect between controllers and the electronic board. Now, there's a limited amount of phones that are allowed in the competition. I think it's the Samsung S5, the Note 3, the ZTX. Check on the site. But basically what happens is you have one phone on the robot, one phone on the driver's station, and the two phones talk to one another. So I'm just going to go through a couple steps. On how to connect the two phones and make sure all the electronic works. So, first of all, take both of your phones and you have to configure the device to change the name. This is one of the first regulations that you have to do so that phones don't mix up. So you start off with you go to settings of your phone, then Wi-Fi. You hit the three dots and go to advanced, Wi-Fi direct, and then configuring the device. Then you change the two names of the phones to the number of your team, like 5987, dash, and then the type of phone that it is. There are two types of phones. There is the robot controller. Robot controller is the phone that's on the robot, and the driver station robot phone, which is the phone that's in your hand when you're playing. Now, if you have more than one pair of robots, if you have more than one pair of phones, you add like a -A, -B, like RC-A, DS-A, and then RC-B, DS-B. You hit the Never Disconnect button, and then you press Save. Okay, so then you have to install the apps that are already made by FRC from the Play Store. On each phone that you name the specific type of phone, you have to download its specific corresponding app. For example, on the robot controller phone, you download the robot controller app. The FTC driver station, you download the driver station app. Now, after you've installed both devices, I'll just explain a little bit how it works. Like I said before, you have the two controllers that are connected by USB to the driver station, and then they talk to each other using the robot controller. Now, you also get information from the robot controller, which is a very useful thing for the competition itself and debugging before. For example, my RFTC team couldn't understand why the robot wouldn't stop driving, and they didn't check specific things from the robot controller. The moment they checked it, they understood that the motors were spinning the wrong way and that the encoders weren't working because of that. So it's a very useful thing not only to send the information but also get information from the robot. Now, the first phone is the robot controller phone. This is the phone that is on the robot itself. I'm just going to talk about the UI, the interface of it, so that you can understand the app itself. On the top left, there is the name of the phone, the name that you named it before. There is the three dots for the settings, the configuration, and other things you want to do. And then there's this red stripe that tells you what configuration you're using. It's something I'll talk about more later. Then there's more useful information like network, if it's active or not, the robot status, and error messages, things like that. You generally don't see this phone in the competition because it's on the robot. So mainly you only need these things for the applications itself, like for programming. To make sure if things are wrong. It's mostly for the setup of the electronics, not in the competition itself. Now, the driver station phone is a little more complicated. This is the phone that you see in the competition. On the top left, you've got the name of the phone that you named it. You have the type of configuration, just like on the robot controller. You have the network it's connected to, the speed of the network in milliseconds. This shows both controllers that are connected to it, these ones. Now, they also glow when you press on the buttons, so you can identify which controller is which. Because the controllers aren't exactly identical. Let's say you want the first controller to drive, and the second controller to control the arms, so you need to know which is which. Now here you can see the battery, how much percentage. Here you can see the battery of the robot controller, the second phone, if it needs to be charged. Here you can see the battery of the robot itself, the 12-volt battery. It's important to know that sometimes, if the robot's not working well, you need to check a lot of things on this phone to see what's wrong. It could be that, let's say, the battery has not been charged and then the motors don't spin. It could be that the phone on the robot is off. It could be that you didn't turn on the controllers. It could be a lot of things. And if it's not any of these, you could see, let's say, error messages in this box. This box is very similar to what we did in the first webinar, the print line, the Bakara, it's called in Hebrew, so it doesn't really help you. Here you could see messages that the robot prints out. So it's very useful, for example, to print here everything you can print. The angle of the motors, the angle of the robot, the distance, all the sensors, because then when you have errors in your code, that we'll talk about in the next webinar, you're going to want to see what those errors are. And using the information that you have is the best way to find out what's wrong. A couple more things about this in general. You have the left and right arrow. These are like these pop-ups that let you choose the program you want to use. Almost every team uses more than one program in their competition. We have, in our FRC team, we have around 16 different autonomous codes. So how you do this is you press on the right arrow if you want to use a teleop program and the left arrow for an autonomous. I'll talk about the basic differences between autonomous and teleop, like the phrases themselves. Next webinar, I'll talk about, the actual code differences between the two. Teleop is the phase of the game where you can control the robot. This is the 2-minute phase. You can move around the robot. All the programs that get inputs from the controllers go on the right. Autonomous is those 30 seconds of the autonomous code. That's what goes on the left. Then you've got this initialize button. You're going to hear a lot about this in the rules themselves of first. You press it once to initialize it. Initializing the robot basically means you put all the motors in their default places, you set all the variables to 0, things like that. And then the moment you press initialize, you press play, and then the specific program runs. Now, from last year, what I remember, There's a lot of very specific rules about this. For example, when you're doing autonomous, you have to press the initialize button, and then when the person whistles, you have to press on the play button. There's a lot of rules about this. You should probably read it up. They're not very big, but you could still lose points over some of those rules. Let's see, did I talk about all of it? Yes. Okay, so you have your electronics, and you want to give them names for the competition. So what you need to do is you press on the 3 dots. Hold on, you know what, I'll stop the questions. Are there any questions in the meantime about what I said? Hold on, I'll open up the Q&A. No? No? No questions? Okay, moving on. So you want to, you have to make sure the phone registers the electronics themselves. So what you need to do is you go through the robot controller phone. You can always rewatch this later because you won't be doing this right now. You go through your robot controller phone. This is the phone that's on the robot itself. You need to connect to this phone everything you want to have on your robot. So you connect to it, let's say, the rev, like in this example. And then to the rev, you connect all of the motors you will be using before you do this step. So what you do now is you press Settings, Configure, and then after you press Configure Robot, you press New, Scan, Expansion Hub. This is the Rev Expansion Hub. You press on it, you press on the other expansion hub, and then you get a list of all the ports on the expansion hub itself. You have the motors, the sensors, the servos, the I2C, which is something very specific. Then you press on the specific thing you want to edit. Let's say I want to add a motor. You press on motor. Then you set the specific port. You give the motor a specific name. This name matters, and I'll show you an example of how you will need it later on. Then you say what type of motor it is. You hit done. You do this also for the servos. You give it a name. You press done. After you're done with all the motors that you created, you hit save, and then you give that configuration, which is the thing I talked about in the red stripe. You give it a name. This is basically the settings of your robot. Okay, now I'll talk about these specific devices right now. Hold on. Okay, so there's a lot of different ports on your expansion hub. Each one of them has a different use. Also on your core legacy, there's a bunch of different sensor types, and each of them has unique properties. So there is your motor, your power cable. This is just a normal 12-volt power cable. You have, on the expansion hub, you can actually, they wrote down next to each type of connection, what it is. So this makes it a lot easier for our device management. So there's 4 types written down over here. There is analog, digital, I2C, and PWM. Any of you who uses Arduino, you might know these names, what they mean. But basically, analog and digital are inputs of specific variables. Let's say they're both inputs for sensors. The difference is in the type of information they get back. For example, the digital sensors only give you yes or no, like Boolean Java. So to this part, you connect all of the Boolean sensors. For example, a touch sensor, a sensor like a pressure plate, things like that. Things that can only give you yes or no. Then there's analog sensors, which are things like temperature sensors, distance sensors on the Lego, things like that. So that's the difference between digital and analog. I2C is for information that you can't give with only numbers. You have to, like strings, if you want to say, or multiple amounts of information. I2C could basically be anything it wants to be. Mostly there's 2 uses for I2C in your competition. There is specific sensors that use I2C. For example, a sensor that gives you both color and distance. Now that's more than one number, so it doesn't work on analog and it doesn't work on digital. So it uses I2C to give a lot of information at once. And then the other thing you could do with I2C is connect 2 expansion hubs together. How you do this is connect the power switch, the battery to one expansion hub, and then the batteries to that expansion hub. Then you connect between 2 I2Cs on both expansion hubs. So basically those expansion hubs will give information to each other. Then there is the 3rd and last type of the 4th and last type of information, and that's PWM. PWM is output. It's a number output. Right, it's a servo. Let's say, right, there's like a temperature sensor that gives you a number from a specific scale of numbers. Well, PWM gives a specific motor a number from 0 to 1. So things that use this are, let's say, smart servos. Servos basically work by position. You give them a number, and then they convert it to an angle. This wouldn't, let's say, work for a motor, because a motor works on 1 and -1, not a scale of numbers. So those are the 4 different types of connections. You could see that on the program itself, there is a difference between them. So you have to know to what your device is connected to before you press it. It changes it. So then after you configure the rev, I'll show you how you configure the modern robotics. It's pretty similar, but instead of showing a hub and then a specific expansion hub, you just see like all the different types of cores that are connected to the power distribution model. Now, in this photo specifically, this is a photo from our team where you see the different types of where they're not called motor and servo. You can also change the names yourself if you feel like it. Now we'll talk about specific things that can go wrong in the code and some specific things that you need to know for the programming itself. The names themselves, as you could see in this example on the bottom left, how the code works is it takes the lift motor, let's say, for example, and then it sets it the motor that was called the specific name that you named it. Now, so you need to make sure you name them things that you'd remember, things that you'd recognize. Because let's say, for example, our team, the FCC team, they forgot the names and then they confused them up and then the motors stopped working. Okay, are there any questions about the electronics so far? Hold on, I'll open it up. Okay. So, hold on, I'll just check what else there is. That's sort of all of the electronics that there is. Hold on, I'll just exit. Now, hold on, the things, the microphone is not working. Hold on. Okay, it's working again. Now, this is basically it. This is the electronics. Now, yeah, this webinar was shorter than other webinars. The next webinar, we will talk about the code itself, organize it so that in each webinar we talk about one subject. Okay, so I'll just talk a little bit more about what's going to happen in the next webinar. As I said, I'll show you the program itself, the programming that goes into the robot. And I'll show you specific examples from our year and our last year, and show you like specific differences between teleop and autonomous.